Our next lesson is on complex numbers. So consider this equation. X squared equals negative 4. Now I know we haven't really taught you how to solve this yet, but one method that we will be teaching you in a few lessons from now would be to take the square root of both sides, and then that would get us just x on the left because the square and the square root undo each other. And then we have the square root of negative 4. Technically there's a plus or minus there, which again we'll teach you in a little bit. But this is currently a problem. We have not ever taken the square root of a negative before in this class. And whenever we had to, we would write things like no real solution, or it doesn't exist, or it doesn't exist in the real number system, or not a real number, along those lines. Now, although in the past we have said that this solution to this problem was no real solution, today we will learn a more thorough solution for x squared equals negative 4. In order to solve this more thoroughly, we will need to introduce the square root of negative 1 and the set of imaginary numbers. So from here on out, if you ever see the square root of negative 1, we are going to define that as the imaginary number I. So I is equal to the square root of negative 1. I is a number. I is not a variable. It's not like x, it's a constant. I is always equal to the square root of negative 1. If you've noticed in the past, we've never used variables I before. Usually we use x and y and sometimes f and g and p and q, but we never have used the letter I as a variable. And the reason we haven't is because it's actually in math used for an imaginary number. Now, if I take that definition, I equals the square root of negative 1, and let's say I want to square both sides. Now, I squared, well, that's still just I squared, and then the square and the square root undo each other here, and that's just negative 1. So if I take my original definition, I equals the square root of negative 1, and I square it, I get I squared equals negative 1, which is a second part of the same definition. Those two bold boxes are basically the same idea, but one's squared and one's not, and it's kind of important to have both handy so that we could use them. Further, if you were trying to simplify the square root of a negative, we can use this property. The square root of negative b is equal to I times the square root of b. Notice if the I comes out of the radical, it becomes an I. It does not multiply to anything else. It just comes out and becomes an I. So let's take a look at some of these examples. The square root of negative 4 can be rewritten using the property I times the square root of 4. Well, I know what the square root of 4 is. That's just plain 2. So this answer is 2i. The square root of negative 2 is, if I use my property, I times the square root of 2. Now, the square root of 2 doesn't break down at all, so that's as far as I can go. On the third one, the square root of negative 9, if I use my property, that gets me I times the square root of 9, which reduces to 3i, because the square root of 9 is 3. Alright, on the next one we have the square root of negative 12. If I take the negative out, it becomes an I. But it looks like 12 can reduce. Okay, so this is going to be the 2 comes out. The I comes out as well. It was a negative, it comes out to be I. And then square roots of 3. Now I have in some textbooks seen 2 times the square root of 3 and then I behind it. This is totally okay, but I'll tell you why I prefer to put the I in the front. Let's say you were just really sloppy that day and you were just writing your square roots, but they went a little long. Well, if your square root went a little long, that's wrong. The I cannot be underneath the radical. There is no such definition for that. But if you are very neat about it and you stop your radical sign right after the 3 and then the I is after it, this is an okay way of writing it. But if I write it with the I in the front and my radical goes a little long, no harm done. It doesn't make the I under the radical at all. So that's why I prefer putting it in front. On our next problem, I'd like to take the negative out and make it an I in front of the radical. 32 looks like it can break down maybe 4 and 8, 4 and 2. Now I know 4 can go further, but all I'm looking for is a group of 2, and I have it. So 4 goes out of the house, 2 stays home, and the I is out of the house. I prefer it in the front. Okay, on this last problem, a lot of students want to take this negative and the negative on the inside and multiply them and be like, oh, a negative times a negative is a positive. Well, that's true. A negative times a negative is a positive. But the negative inside the house and the negative outside the house can't actually multiply. There's walls between them, right? This is like one person inside the house and one person outside the house. They can't talk to each other. So this negative, the only way for it to come out of the house is for it to become an I. Please, please do not multiply those two negatives. They can't talk to each other because one's in and one's out. Now 20 looks like it can reduce. I've got my pair of 2's. So we have the negative because of the negative in the front. 2 because a pair of 2 comes out. I, the square root of 5, stays home. Now that we've had to practice with some imaginary numbers, let's revisit our first question of the section. X squared equals negative 4. If I square root both sides, again we'll talk about this method in more detail in a future section. That gets me x because the square and the square root undo each other. Then I have the square root of negative 4. It's actually plus or minus, again for a reason we'll talk about in a future section. But what is the square root of negative 4? Well, the negative comes out and becomes an I, and the square root of 4, well, that's just 2I. So when I had my solution of no real solution that we've been teaching you for years, that, oh, this thing doesn't work, you can't take the square root of a negative. Well, I'm not wrong, okay? I wasn't telling you the wrong thing all these years. It said no real solution. This clearly isn't real. This is imaginary. So all those years you've been saying no real solution, you're still right. It's not real. But now that you have more information and you know what imaginary numbers are, you can't put no real solution anymore. That's not sufficient because you know that your answer is imaginary and you can actually find me your answer. You need to give me the answer in imaginary form from here on out in all of your mathematical career. Now what happens when you have real numbers and imaginary numbers and you're trying to manipulate them together? Well, in this case we get a complex number. A complex number is a real number added, really, or subtracted to an imaginary number in the form a plus bi. This is super, super important. A plus bi form, where a is the real part, it's the real number, and bi is the imaginary number. All complex numbers must be written in this form, a plus bi. You have to put it in that form. On the next section, I want you to identify the real part and the imaginary part of the following complex numbers. So 5 plus 2i. Notice that the real part's in front and the imaginary part's in back because it has to be in a plus bi form. So who is the real part? 5. Who's the imaginary part? Positive 2i. As simple as that. On 12i, what is the real part? Well, that's kind of a hard question. We clearly can see that this 12i is the imaginary part because it has an I. Another way of thinking about this is like no real numbers plus 12i. So the real part is just 0. On our next problem, x plus 4 minus 3i. I know this might be hard to think about having a variable, but we've been dealing with variables for quite some time now, and they've all been real. So the real part is x plus 4. The imaginary part is the minus 3i. Negative 14. Which one is the real part? Which one's the imaginary part? Well, you might be looking at this and like, negative 14 is not a complex number. It's a real number. Well, clearly the negative 14 is the real part, but you could put a plus 0i. So the imaginary part is 0i. So in this case, this one is 100% real, but if you make it into a complex number, the real part is negative 14, the complex part is 0i. On 12i, the second one, the entire thing is imaginary. Well, if you write it as a complex number, the real part is 0. So we can make any number into a complex number.